You light our homes. Keep us warm.
You help us explore, innovate, and achieve the unthinkable.
You are everywhere.
Yet, sometimes out of reach.
You move us forward and bring us together.
And together, we're on a journey towards the future of energy.
So what will it look like?
It's hard to say, but we know it will be sustainable and abundant.
We're already on our way.
With a common purpose, each of us playing our part.
At Deloitte, we're connecting every bright mind, every organization, every startup, every innovator.
Every citizen, CEO, and regulator.
Making this future happen won't be easy, so we're developing practical solutions.
And a clear roadmap to help our clients on their way.
We'll keep making those connections
Each step well planned, moving forward together.
to make our new energy future a reality. Let's connect for a new energy future.
We will have a chit-chat here, hoping that we'll be heard outside. I would like to invite everybody to a very interesting panel. The panel will be devoted to advanced software solutions for the carbon economy, and I have great guests next to me. Right, that was an attractive pitching. We certainly wanted your attention, and we want you to join us here. And that's an actual premiere. So IT solutions, IT companies in hydrogen-related technologies. It might have seemed strange, but actually when you give it a deeper thought, it appears as obvious that, well, cutting-edge solutions support technological advancements, supporting engineering, supporting design has been with us for years now. But today we are going to talk about support in the context of hydrogen and hydrogen technologies. We will talk about solutions regarding gauging equipment or power-related systems, but we also mention IT technologies pertaining to this area. And then we'll talk today to a company that not only designs but also implements its solutions in this realm. Piotr, I believe we can start. That's right, I agree. And the floor goes to Kasia. Let me introduce Kasia, if you don't mind, okay? Traditionally, okay. So the panel is entitled Advanced Software Solutions for a Low Carbon Economy. And the panel should be moderated by Katarzyna Więckiewicz-Dominiczak, CEO of Sim Engineer. With us we have Anna Wujec, Digital Lead Poland at ABB. Thank you very much. Thank you for the invitation to this conference. We've got Mr. Mariusz Paszkiewicz, CEO of Inwebit. Good afternoon. And last but not least, Mateusz, Kasprzak, Business Development Consultant at Yokogawa. Welcome, ladies and gentlemen. I also thank you for the invitation. And I think it is worth noticing that, maybe with the exception of our guests from ABB, you are members of the hydrogen technologies clusters. Maybe ABB will join us soon. I feel provoked now publicly, but maybe it is worth noticing that ABB is one of the sponsors of our conference. So thank you. We appreciate it. So we are all interrelated. Thank you very much for the invitation and making it possible for me to moderate the panel. I believe we will change it into a discussion more than me just asking questions, as the topic is vast enough and interesting enough for a discussion to be potentially rich in unexpected but very interesting topics. We are supposed to talk about software solutions, so solutions concerning information technologies. Information today is about the most important and the most expensive thing to obtain. It's also a basis for building strategy and for development. I have a question to Mateusz. What kind of information technologies, what software solutions are offered by Yokogawa? Well, I think it's a question that I think each of us would answer differently. And that's the beauty of software solutions, that software particular problems or may resolve particular problems. That will depend very much where the root cause is. Anyhow, taking part in a number of talks with bigger and smaller entities and institutions concerning the implementation of green hydrogen technologies, I often encounter a question: why do I need the software? How am I going to benefit from having it around? What justifies it economically? And in what way the software that we are talking about will contribute to me seeing hydrogen costing €2 per kilo in a few years' time, and even less in even longer time. I'll try to provide you with an answer from Yokogawa's perspective. That's a Japanese company that has been around for years now and that automates industrial processes and provides software. So I will focus on this perspective. I will focus on software and software enabling and supporting automation, but also from the point of view of big companies and a very interesting Japanese market. I will also give you some examples, as actually Japan started this revolution already some years ago. So we will see how software can support the installations, and we see three major criteria that hydrogen installations of the future need to meet. They need to be optimized, they need to be integrated, and they need to be autonomized. It may sound trivial, because actually anything has to be optimized, integrated, and autonomous, but actually the devil is in the detail, and there are many solutions around that we will probably talk about. They are available and they do support all this. So let's go through the three aspects. Optimization of hydrogen installation, the production of green hydrogen. What does that really mean? With the systems generating green hydrogen, we have three areas that we can optimize. The first and basic one is the way in which we supply this green energy to the electrolyzers. Most of the projects that are implemented now, the large-scale ones, are based on the PPA agreements with the suppliers of renewable energy that is delivered to electrolyzers based on the PPA agreements. That's a straightforward solution that does not burden us in terms of creating new systems. The only challenge is this technological one. It is not an optimal solution, though.
When it comes to energy supply to the electrolysis process is the share of renewables in the energy market of real time, or along with batteries or other energy storage and using software solutions such as controllers of micronetworks or renewable energy sources, we're able to maximize and stabilize the quality of energy provided to electrolyzers. Another aspect is optimization of hydrogen production, the electrolyzer itself. Here we're talking about APC type solutions, which can stabilize or speed up the serving of electrolyzers. And they also allow us to detect microcurrents in electrolyzers, so we know what is their effectiveness, what is the aging process of electrolyzer sets. And final piece of optimization is what we're going to do with all this hydrogen. Today we've heard quite a bit about it, about what to do, how hydrogen can be used in caverns to balance electro power grids, and how we can use hydrogen in demand response systems, or how we can manipulate or how we can basically adjust the users, or in other words, how to supply the hydrogen in accordance with the contracts that we have, so that it's most profitable, so that we can build this economic advantage. That's when it comes to optimization. Now, integration, and here we have two aspects. The first aspect is internal integration. Hydrogen installations are relatively simple installations, and already we can see that they're being created in a modular way, as individual elements are provided and have the internal control, steering. It's of course of key importance how we integrate it all into a single environment with possibilities of remote access and all cybersecurity connected with it and so on. It's also very important how we are going to integrate all of these assets with information coming from the outside, because for green hydrogen installations to work in optimum fashion, they must get information about weather, about energy prices, about signed contracts, legislation, liabilities, and so on. And the last aspect, automatization. So when these automatization, so once we have all this information, we can build such decision-making processes and green hydrogen processes when based on many external and internal variables, the systems are able to autonomously work and autonomously in this manner that we have a system of building decisions and scheduling the works, which every 5-10 minutes updates the entire method of installation operation for the next 48, 72 hours, but we also have a system in which these informations are being provided in an autonomous way to a control panel in various parts of the installations. This is quite interesting because we have steering components and thermodynamic part where we have hydrogen, where we have standard PDI regulators which are working with this frequency of up to 2-3 seconds frequency. However, at the same time, we have an electric part. And there we have the answer time, regulation time is up to 60 times a second. So you have to build such chain of command which is able to deal with these two worlds and optimize it in the entire range. Thank you very much for this very fact-filled response. A question to Mariusz now. In your fantastic work, which I've learned about, I think it's at a very high level of sophistication of investments as far as software environment is concerned. So the same question, because you seem to be a synonym of IT technologies. This is your second name. So please tell us more about what you're doing, or how important is information for you. Well, just very briefly about the company. We've have been providing system for the energy sector for the last 5-10 years, systems, but also all the devices that control hydro energy and other renewables. In 2019, we provide virtual energy plant to our operator. Now the question could be, why hydrogen in a company like us? Because now we are dealing with electrolyzers, with building of tanks, entire systems which are going to integrate it. But where did the idea come from, this software company? During the implementation of this virtual plant, the operators were responsible for modeling mathematical models and AI when it came to prediction of energy price, prediction of how this hydropower plant functions with hourly plan, how it's going to behave the next day. We had to know exactly, we had to model how all the energy sources are going to behave, including their profile of use for particular objects. And with this information in mind, put appropriate transactions on the market, on the energy market. After implementation, it turned out that, of course, operator does have energy storage, but according to our calculations, in order to effectively, and in fact, well, the operator wants effective, beneficial ways. Now, to use it, we need about 8 to 9% of so-called control storages, which we're going to be able to use in case of various undesirable events, which might take place. Operator set 8-9%, and when we counted what its capability, then the operator smiled. No, we can say 1-2%, and it's a lot for us. And of course, we also talked about lithium-ion solutions, battery-based solutions. When 2018-19 were already employed, they were quite expensive, quite prone to malfunction, and they were quite large when it comes to dimensions. So, and 8-9%, these were megawatts. These were not small amounts. So these were the amounts needed to obtain benefits on the systems. So in 2018, in such a company as ours, appeared the idea of chemical accumulation of hydrogen, and an idea which I'll say a few words about. That is also the idea about ammonium, storage of ammonium, and creating hydrogen out of ammonium, and from it electrical energy. So the idea was created due to lack in storage. But coming back to your question and answering your question, for 10 years we've been working on virtual electric plants, measurements taken in very large facilities, and information is of key importance. But in order to use hydrogen as energy storage soon, well, we would need a lot of information about all the elements, all the measurement points, in order to build AI properly based on hydrogen. to build a neural network which is responsible for concrete decisions. We need dozens of thousands of pieces of information from concrete measurements of specific elements to take such decisions. Now, well, for the elements that we have now, such as battery-based solutions and renewables, even in hydro plants, we are able to implement such models quite efficiently. However, in case of hydrogen, it's an element where we're just starting out. And here I can say that, yes, in the last panel, we've heard something interesting. And here I can say we were able to obtain quite a lot of funds from the Nowa Energia program for building a hydrogen energy station. We, as a software company, our customers, our clients come to us, which can be divided into two types. The first type is client comes, they have a lot of energy, and they want to have certain business advantages on the sale of this energy. And the client also wants to do it in a way in which it will bring him the most benefit. So they have either wind or photovoltaic panels. But in fact, the hours, the good hours in which these best benefits can be drawn are completely different from when the generation takes place. So this client thinks about storing energy in hydrogen and then playing when the energy price is the most attractive. And the second type, which is more and more frequent these days, these are clients, these are SMEs, small, medium production plants where they have small energy sources. Perhaps at first even they were not all that happy with, they were kind of happy with buying these energy sources, but once they start doing the balance, the result is not very good. They want much more, much better. They want to think about the level of being self-sufficient, about kind of horizontal or level-based self-sufficiency, because they set levels depending on budget. So we have these two types of clients which differ. So you have this self-sufficiency, and you also have those playing on the energy market, and these software solutions to a large degree differ depending on client. Now, summing up the hydrogen energy station we want to build within the next 2 years. This means a station, and when this information from prediction, from the energy markets, or from the profiling of concrete clients, small, medium, large, this means that to the scattered architecture of equipment, information finds its way there how to work. And this AI, which is located at the hydrogen storage, at the electrolyzer, is supposed to take appropriate decision, allowing for concrete value of energy to be produced by these electronic sets that we have, and then provides information about the central system so that this self-sufficiency can be maintained at the level that the client assumed, or to play on the energy market in those hours when the energy price is the highest. At bottom, just a couple of words. A topic that was not mentioned, I think, yesterday or either today, and I think this refers to what you just said, Mariusz. Hydrogen as an energy source, and also batteries. We have to be aware that we need micro networks in Poland, within institutions, within companies, and hydrogen is one of these tools which can quite easily stabilize these micro networks. So the topic of micro networks have to appear very quickly, not just with talks with clients, but also with self-governments. And you've mentioned optimization, etc. The truth is that looking at costs, we are building electrolyzers, and the costs of these installations are not small. If we're talking about costs, it's not a system where they receive something and they get something. the system is necessary to atomize the installation. So you pay for this installation, but you don't know. The truth is that such systems, which act on such systems, they have to work very strongly, not just on the benefit, but soon we'll talk about safety in a few seconds. Perhaps I'll turn the floor over to Anna now, but this just testifies to what a hot topic this is. And as I can see, information management is a very important aspect in hydrogen technologies, not just infrastructure, which is very important, even though information management is of key importance. And ABB, a true patented main player on the market, multidisciplinary technological firm. How does information management, how does use of information, what does it look like as far as use of software solutions? Thank you very much. I'll return to the rate of return because in my everyday work I deal with helping entrepreneurs understand advanced software solutions, understand how to use new technologies, how to prepare them for adoptions in their companies. But I'll try to end with put a certain conclusion on the last panel with what my colleagues have initiated.
I mean, the approach to the use of information and process safety. Why is it that important, both locally and globally? We can see one trend. Hydrogen economy lies in the interest of the companies that have process safety expertise. These are companies from the chemical sector or refineries, for example, and these companies very often already have some experience with gray hydrogen in their projects. They also take green hydrogen into account, but there are a lot of companies that are novice, who do not know and have never touched process safety. And these are the companies that come to us for this specialist knowledge so as to know how to handle the hydrogen, both in production, distribution, and in transportation. Why is it that important? During the previous panel, we already mentioned different parameters of hydrogen. In certain concentrations, it can be explosives. It can burn with a flame that is not visible to the human eye. The temperature, the energy of this flame is slightly lower than in the case of other carbohydrates, hydrocarbons, but it can be a threat to a human life. It also has a low temperature, ignition temperature, so it may induce a number of reactions that make us design safe systems along the entire hydrogen chain. Now, regardless of which company is concerned, whether an experienced one or a completely new one, 3 steps are necessary. First of all, building solid foundations for the culture of safety. Secondly, identification of threats in the area in which a given operator wishes to operate. And then designing safety measures at the stage of design, or even better, at the stage of concept development. And step number 3, verifying of whether what has been designed really works. Now, how advanced software solutions can come in handy? Well, first of all, they can manage this safety. They can lower the cost of maintaining safety and maintaining operations, and they can manage risk. And this safety-related risk is a business risk. Maybe some practical examples. If such safety systems are used at the design stage, we can significantly lower the cost of engineering, and we can then talk about a project that has a higher quality over its lifetime. If we do that at the stage of operations, then it is possible for us to identify the threats, the risks, well in advance, because what we use is big streams of data from office systems, operational systems, engineering systems. We compare the project with the current situation, and then we can establish which safety level is represented, and we are always a step ahead of a potential incident. So in real time, we can decide about the level of our safety, about the status of our safety. How does that impact costs? Let me give you an example that will illustrate that. It was an actual implementation. We know that safety control requires tests to be performed, and these tests always, in a way, distort the work of technologists, of maintenance experts. They're needed, but they always constitute a kind of intervention in a daily activity. About 30% is the proportion in which we can limit the cost of these tests, gaining the possibility to react in real time owing to these computerized systems. Thank you very much. I actually like this argument very much because I represent a design office that actually designs mechanical infrastructure, including hydrogen related one. And we also offer safety engineering, CRD simulation-based solutions. And it has been a common occurrence that normative formulae were overridden by those computerized one. It proved that our outcomes were the right ones, even if they were contradictory to certain standards. But standards are often averages taken from some historical data. So safety is a key issue, and we also prefer those projects in which we have control over it right from scratch or from the design stage, and not at the point at which something wrong is already going on. So we love to design infrastructure so that it is safe. We wish to have some impact on the distribution of sensors and defining how they should react. And then you take over, and you too, taking care of the installation itself. Or to put it differently, it seems that we represent various areas of engineering, but actually it appears that we are really complementary, and that is where our strength comes from. We can support one another with our expertise and experience, and I'm very interested in how Mariusz approaches risk assessment, because I don't know if you use neural networks, whether it is heading in this direction, but well, I'm passionate personally about artificial intelligence, and it appears that you need a massive amount of data to create such software solutions. At which point, at which area is it beneficial to humans, and where is this moment at which it starts to constitute a threat? That's a question that recurs when talking about AI. But before I get to addressing it, we talked about safety, and it's interesting because in this discussion, each of us sees safety differently. So let me tell you how we perceive it. So safety in relation to hydrogen. First of all, we've got energy safety. Energy security. Oh, this is something that is information from the client that has a small, medium-sized, or a big plant, and they think how to get independent from a grid connection to such an extent that they are able to keep on offering their services. And this is this energy security that, of course, has increased after Russian aggression. We see it in the clients that approach us, but actually it started earlier on amidst the pandemic. And that's interesting that the pandemic time showed people to start thinking towards energy security, ensuring the energy supplies for their own purposes and their companies' purposes, and the number of customers that started coming to us and the budgets that they started to allocate towards this goals are very promising. We've always taken care of energy efficiency and energy security, but actually now this has become a luxury product. But everybody wishes to be able to have it. And the production companies, the small and medium-sized ones, wants to have the energy supply regardless of whether it is available in the general grid. So that's energy security. Then we have a definition of these clients, big clients, who once say we would become green by 2030. And now they're coming to us and they say, look, we are supposed to be green by 2030. We've got some renewable energy sources already. And we already see that our plan, and these automotive big companies, they have high energy consumption and they know that they cannot build any storage solutions for RES. And we do not talk about energy security. Simply, there is a high probability that they would not really make it till 2030. So looking at hydrogen, they will find it really hard to become green because their consumption is on the increase. They produce more and more, and they are not in a position to ensure this energy. Another component of safety or security is what Anna's mentioned, but we treat it more from the engineering point of view. We build IoT solutions that are control and measuring solutions, and they ensure this security. The data gets to a neural network that has been trained properly on the basis of several dozen thousands of samples. And the neural network can take and make a decision. Of course, it's 90-something% probability that this decision will be right, but still there is this minor percentage of probability that it won't. So this is this element of AI that makes decisions whether, for example, an adverse event has occurred. And this is this kind of engineering safety that simply alerts the operator that something is wrong with the system. And the third aspect, a marginal one perhaps, but might be of interest to you, is the critical infrastructure safety. We have a big division devoted to smart city. We built an urban lamp that detected terrorist faces, explosive explosions, shooting, and so on. Owing to the pandemic, the interest has dropped, but actually power operators were interested because they wish to protect their critical infrastructure. So it might be so that big hydrogen installations and systems will be at the risk of some adverse incidents happening. So they will need to have some systems for identifying the events that are potentially dangerous, like terrorists and so on. So this is this security of critical infrastructure, which is a case also in terms of hydrogen. Now, about safety, security, and learning and teaching. Now, drawing on to what we've heard from Anna. So how to transfer best practices from refinery companies, from the companies producing ammonia or fertilizers, to smaller systems that will be popping up and that will be related to hydrogen. Even if we transfer some standards, some norms, and even we have some systems watching over them, automated ones, there is still this operational aspect. Yesterday, it was nicely shown within the panel about functional safety, when the firefighter showed a simple solution with the flame that one cannot normally see. Every fire engine has an infrared camera that makes it possible for you to actually see the hydrogen flame. The question is what to do for any person that goes to the installation, takes this camera with them, and applies it. So how to build good practices in companies that do not have big organizational structures, that do not have big staff numbers, big headcount, how to persuade them into upkeeping the safety standards. And this is a question that many of my clients ask me. And the solutions that are software-based can be really helpful here. Not only do they order certain processes in the company, for example, authorization for work, change control, and so on, but also they have a certain database and the base of best practices that was created together with those big hydrogen producers who know about these issues, and this knowledge is to be used by the smaller ones. So they get a full menu on how to act in a given situation, what tools, what protective measures they should apply. And that's yet another aspect where software can help. Let me add that these adverse events that can happen that we do not foresee or design protection against can also slow down the development of this promising hydrogen economy. There was such a situation in Norway in 2019 of Oslo. There was an explosion of a hydrogen fuel station, and for a number of months this topic was completely blocked, put to a halt. So this process-related safety is very important, and safety and security at the same time. Let me add another aspect related to security, namely cyber security. Hydrogen economy and all the entities that will be involved have been obliged by NIS2 directive to approach cybersecurity in a very careful way. There are 4 different important areas here. First of all, you need to take care of the basic cybernetic hygiene, so basic practices related to cybersecurity. Secondly, you need to meet the industry standards. Thirdly, you need to monitor your infrastructure. And fourthly, within 24 hours, you need to report any breaches to the appropriate authorities. As for advanced systems, this area of monitoring will be particularly important. The systems for monitoring of the grid and those for monitoring events, incidents from all the systems that we have in our infrastructure and their components. This has to be assured. Why is it that important, and why is this emphasis put on monitoring? If there is a cyber attack in an office net or any smartphone or your personal computer, then you see the result of it either straight away or within a few hours from the attack. If somebody plans a cyber attack onto critical infrastructure, then the average time between this moment when there is the attack and actually the results being visible is on average 90 days. The intruders try to localize all our soft spots, and they get ready to carry out this key neutralization exercise. If we have supervision or monitoring systems, we can get ready for this kind of event, and we can detect as soon as possible the fact that somebody tried to breach the security barrier. The NIS2 directive, within just 2 years, will be transferred onto the national cybersecurity system. It is worth taking this aspect into account already at the design stage. Just one sentence, this is particularly important when power engineering was so central and centralized, it was easier to hold the cybersecurity together. Now, for 3 years, we have been introducing a highly decentralized architecture to power, and these processes had to be remodeled by definition, and BDF of the guidelines concerning safety-related issues pertaining to a system operating within a dispersed architecture is in itself a thick book for a given system. So it looks differently depending on whether the power system infrastructure is decentralized or centralized. So these processes will concern us too. You can see that the debate is heated. It is hard for me to really intervene, but I would still like to refer to what we've heard from Mr. Mateusz. I don't know if you remember LPG and the uniform that the worker of the fuel station had to wear in order to be able to fill up the tank. Now we have to make a difference here between industry and the public area. These are 2 different worlds, 2 different sets of standards, and that exercise is still to be done. As for cybersecurity, that's a very important issue. That is why we as enterprises have started introducing the service of cybernetic safeguards based on quantum technologies in partnership with a German company. We know that it is complementary to our clients, that they need those protection measures, particularly this year. They ask for that, and we will provide it. So apart from the fact that we have physical infrastructure, we also need to manage information and protect it all. Unfortunately, these areas offer themselves as easy targets. This decentralization also costs this race here for winning over new areas in the hydrogen economy, what the installations are concerned, the use of hydrogen. It is different in Western countries where there is a greater drive towards cooperation. The companies do realize that this critical mass has to be built up in order to be competitive in the market. Single-handedly, no company, even if it was the biggest one in the world, cannot achieve it. So how do you see the potential for cooperation, integration across different sectors? Maybe Anna would start. What comes to me are 4 criteria that have to be met by advanced solutions in hydrogen economy. If you take into account the integration aspect, first of all, interoperability, so readiness of a system to cooperate with varying infrastructure and systems, both those of today and of the future. This guarantee within ABB system has to be given to the clients by the companies. And managing complexity, what is typical for hydrogen economy? First of all, we have a few forms of energy. And we keep on searching for this golden balance to resolve the power dilemma. We have a complex and dispersed and highly varied infrastructure. We've got clients who would like to use different market mechanisms. And there is the 4th aspect that I can see today in other European countries when I talk to clients. This is something I haven't found in Poland yet, and it is the necessity of ensuring our clients with the dynamic opportunity of adjusting their business model so that they can stay competitive in the market. You can see that in Germany and Italy in particular. I haven't seen it in Poland yet, but this is the 4th criterion in terms of complexity. We talked about the fact that these systems are to be cyber-proof, and the last important aspect is a guarantee of profitability. So the software solutions we are talking about, to my mind today, make it possible to optimize one's capex and opex and the price of hydrogen in the end. And surely hydrogen economy will be digital. I'm deeply convinced about that. And we have 2 clear groups of software solutions that have their impact on it. Simulation and compilation of multiple technologies, that is digital twin. At the stage of designing, we can optimize its costs with a focus on the cost of having and not of designing. And another area that is particularly close to me, these are systems for managing energy. These are optimization systems that have the highest return rate today, back to their profitability. Now, a few months from the implementation of such a solution, enterprises can already talk about the return on investment, happy about using them. Hydrogen economy is rather specific here because particularly at any stage of the chain, we have 30 to 40% of energy losses. I cannot imagine hydrogen systems that wouldn't have such losses, but also the systems monitoring the situation. So 4 important criteria for advanced systems as far as integration is concerned.
a proverb comes to mind, or a saying that good IT specialist uses open source codes. So you're using something that is available. That's where IT is developing so quickly, because that's the way they work. And I think we need to change our mindset when it comes to hydrogen technologies and shared knowledge. Of course, it's important to protect our intellectual property and so on, but we should also share our knowledge, be open to cooperation. Perhaps, gentlemen, you can say a few words what it looks like in your case. A few words regarding cooperation. I think Anna exhausted the subject as far as solutions, but a couple of words regarding what this cooperation can look like in reality, because as you've said, software systems already exist. Systems which support hydrogen, clean energy economy is there. It's just waiting for projects. However, even when they are there, when they exist, they have to economically fit the projects they're going to be applied in. I would also like to say a few words about Energy Transition Campus. It's a campus which was set up in Amsterdam by Shell. Shell connected about 16 technological companies, which have always been Shell's partner Yokogawa when it comes to optimization, automation, and they said, okay, here you have a place, a building, you have funds, you have a place where you can implement these solutions. Please create creative solutions. Let's start building solutions which will address concrete needs using digital twin, machine learning, using various technologies companies that specialize in that. So that's what it looks like. Yokogawa is there as a chancellor, and many other big companies. They sit down at a single table and they start thinking how we can solve specific problems and implement them in reality. One of the results of these talks is a project which I hope you've heard about, and which Shell announced, Holland Hydrogen 1. Shell is building in Rotterdam 200 megawatt electrolyzer, which is powered by offshore energy. All the hydrogen is going to go to the refinery there, and it's a big scale project, huge project, in which they're using ideas, solutions which were created in the Energy Transition Campus. What's my point? Well, these types of meetings we have, hydrogen clusters are very important because they're the beginning of this cooperation, but on the business side, we can create business cooperation regulations, which make sense, which take us forward, so that perhaps we are able to meet this goal of 10 million tons. Also, well, we as a company, we are perhaps dreamers too much, or perhaps we have this openness coming from software when it comes to open source. But the truth is that AI likes openness. We had a question recently from an institute that builds this tank with us. Maybe you'll make a neural network which will detect this cracking of the tank. You can detect, and how many sounds do you have there? One. You know, if we have several thousands of sounds, then we can tell you that it's cracking or whether it's just filled. So information is needed by AI. That's its fuel. We're dreamers because we think that clusters, valleys, these are going to be the places where such information can be exchanged. I know that this hydrogen market in Poland is quite closed. We try to talk to each other, but the information that we receive about particular events which can affect us, which can take us forward, are of key importance. So in my view, common hydrogen test grounds, shared projects and clusters, collecting information, experiences through various companies. I think this is the key element, key value. It's already been said today that, of course, money is needed, that no arguing here. Difficult to do anything without money. But for us, a software company, which is to be based on this information, take certain decisions, of course, we will build a hydrogen electrolyzer station, but that's going to be quite poor. This information is needed much more widely. So pioneer and innovator, not a dreamer. That's the way it should be. So this critical mass is necessary to be competitive in the world and in Europe, and Europe needs to be competitive. We have a situation where South America is ready to provide hydrogen to Europe in any amount, so if we are going to just sit closed in our labs and build perpetuum mobile, to do 5 PhDs and 5 professorships, then we'll simply miss the train. So having this awareness of cooperation will move the Polish hydrogen industry forward. So all hands on deck. Yes, definitely. So concluding our, complaints, although not entirely, even though I've heard in a few panels that Poland has a bit to do still, which I must confirm, looking at Polish clients, looking at different types of projects being done. I see that you're ready for cooperation, new experience, so are we. I hope that nobody got offended. I hope that we haven't said anything bad. Perhaps a couple of words to end with. Just a sentence or two. Perhaps there are some questions from the room.
Jesteśmy największą metropolią w Polsce Północnej. Jesteśmy otwarci na to, co nowe. Jesteśmy świetnym miejscem do życia. Jesteśmy Trójmiastem. I dlatego zawsze będziemy dbać bardziej.
Korki na wszystkich drogach dojazdowych do Trójmiasta już dawno przekroczyły akceptowalny poziom. Dlatego samorząd województwa pomorskiego uruchomił nową linię kolejową łączącą metropolię trójmiejską z Kaszubami. Dzięki podróży pociągiem tysiące osób może szybciej i wygodniej dojechać do pracy, szkoły lub na zakupy, a potem wrócić do domu. Nie trać czasu i pieniędzy w korkach. Podróżuj szybko i wygodnie koleją. Do pracy, do szkoły, na zakupy.